Well, welcome back to Geometry, my favorite tree, for two reflections. A reflection is a transformation that uses a line like a mirror. Okay, so it's like we have a mirror here, call that line M for mirror, and we're reflecting point P across that line. Now when we're reflecting, we can make a vertical line, a perpendicular line to that mirror per se, to that reflection. Perpendicular line, and then our new point is the same distance away on the other side. So if we're reflecting, that line P to P prime is perpendicular, and M is a bisector to that line because we have the same distance on one side as we do on the other. If P happens to lie on the line that we're reflecting, then P is the same as P prime. Okay, if we're reflecting across horizontal and vertical lines. Alright, let's have a look. Horizontal and vertical lines. So we've got triangle ABC with vertices 1, 3. So there's 1, 3. That's A. 5, 2. 1, 2, 3, 4, 5. And 2. This is X and Y. This is B. And C is 2 and 1. 2 and 1. This triangle is what we're going to reflect. Boom. There we go. Beautiful triangle. And we're going to reflect this across X equals 3. So I go to X is 3. And X equals 3 means that it's always going to be 3. No matter what the Y value is, X is always 3. So there we go. So we are reflecting this across X equals 3. Reflecting means we're going to go to that line, perpendicular to that line, and then the same distance on the other side. So there's same distance. We went 2 away, so 2 on the other side. There's A prime. And that is 5 and 1. B. We're reflecting 2 away, so on the other side, B prime is 1 and 2. And then C, we're reflecting that across, that's just 1 away, so C prime is at 4 and 1. Okay, so there's my new triangle. Now, notice these new coordinates and compare them to the previous ones. Oops, I said 1. Sorry, that is 3. 5 and 3. Okay, notice that Y hasn't changed. For B, Y is 2. For C, Y is 1. So if we're reflecting across a vertical line where X equals 3, the only thing that changes is the X value. And the way it changes is we're reflecting across X is 3. The difference to 3 is here we have to add 2. So we have to add 2 to 3. Add 2 to get 5. So the difference is 2. So I'm going to add 2 to that number, get me 5. And the Y coordinate doesn't change. Obviously the other way around, if we're reflecting across a horizontal line, Y equals 1. That's this line right here. Y equals 1. Add a different color. There we go. All right. Okay, we are reflecting across Y equals 1, and notice that C is on that line, so C prime is going to be the same. If it says Y equals 1 and Y does equal 1, then those coordinates don't change. That's still 2 and 1. Now I'm reflecting B, go 1 over here, we get B prime. and that is at 5 and 0. 2 is 1 away from 1, and then subtract another 1, you get 0. And A is 2 away, so A prime is here at 1 and negative 1. Notice that this time the x value didn't change on any of these. And here's my new triangle. Alright, reflecting across a horizontal and vertical line. Next, I want to show you a few special cases. If we reflect across the x-axis, so I have a point right here. That point is 2 and 1. I reflect across the x-axis. My new point is here. It's still 2, but now it's negative 1. So if we reflect across the x-axis, then if my initial point was coordinates A and B, then I still have that same order A and B, but B is just the same number except it's opposite, the negative version of it. Okay, reflecting across the y-axis, say I have a point here. This is 1 and 3. And I reflect this across the y-axis. I'm going to have negative 1 and 3. Okay, so if I have points A and B and reflect them across the y-axis, then I now have negative A and B doesn't change, right? So if I'm reflecting across the y-axis, the y value doesn't change. If I reflect across the x-axis, the x value doesn't change. Okay, well, let's have a look at a couple other special examples. If I want to reflect across y is equal to x, that's a line, and this line looks like so. Right? Y is equal to x. So when x is 1, y is 1. When x is 2, y is 2. If I reflect across this line, say I have a point right here. Okay, want to reflect that point across this line, I have to make a perpendicular line and then go the same distance on the other side. Now sometimes that distance is a little tricky to calculate, so here is an easy way to do that. I can measure going down and reflect this line across this, which since y equals x is a 45-degree angle, I have 45 degrees on one side, 45 on the other, makes it a right angle, and so I can go straight down and then across. So down 3 to hit that line and over 3 to hit the new line. Now this point was 1 and 4. That's a 4. This point here is 4 and 1. So if I have points A and B for my coordinates, then over here we're going to flip those around, B and A. Alright, and another special case, if I want to go in the other direction, y equals negative x. Similar case, we have a point right here. Let's reflect this one. Oh, nope, that's about the same situation. Let's try this one right here. Okay, we could go diagonally, like this, a perpendicular line, or, like I showed you, super trick right here, I went down 2 boxes, so I'm going to go over 2 boxes. So now, I started with coordinates negative 2 and 4. My new coordinates now are negative 4 and 2. So you start with A and B. We flip those around if we go across y equals negative x, and we get negative B, and negative A. Alright, our postulate 4.2 is the reflection postulate. A reflection is a rigid motion. That means we don't change any part of this shape. Angles are preserved and lengths are preserved. A glide reflection takes the first point, does a transformation, and then a reflection. So it's kind of like it's gliding, moving along. So I take this line PQ, move it along to P prime, Q prime, and then reflected to get Q prime prime and P prime prime. Alright, let's look at doing one of those glide reflections. Here I've got triangle A, B, C. A is at 3 and 2, B is at 6 and 3, and C is at 7 and 1. It says use the translation x minus 12. So the only thing that we're changing is we're taking the x values and subtracting 12. The y values don't change. So this is just a transition 12 units in this direction. Right, minus 12. So I'm going to take this and I'm going to count 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right here is A prime. Alright, we're going to save a little time, do a little bit of magic, and move this right over there. Boom. Okay, because since this is a rigid motion, the triangle doesn't change. So instead of counting every one of these, you could just from here count up 3 over 1 and down 1 over 4. Alright, now we are reflecting across the x-axis right here. So down 1, boom. C prime prime, B down 3, there, B prime prime, and A down 2, A prime prime. And there is a glide reflection for you. Finally, lines of symmetry. A line of symmetry is a line that you can reflect a shape over and map it onto itself. So, for example, this shape has a line of symmetry here and one here. So I could reflect it across this line and get this point. Across this line, get this point, or across this line. So that one has 2 lines of symmetry. This shape right here actually has a lot of lines of symmetry, not only from corner to corner, like this, but also through the middles, like so. Sometimes you have to look twice to make sure you haven't missed any. And then finally this shape only has 1 line of symmetry. And that's all for this lesson. No, it's not. Haha, just joking. All right, here we have a problem. We want to figure out where to park because your friend wants to get books, you want to get music. So what's the closest way for each of you to have the shortest way? Now notice that this is the same distance from the line, parking line right here from the road, as A is. So since these are the same distance, what I can do is I can reflect B across this line, same distance, this distance right here. I'm going to go that same distance underneath. Now I can make a line from B prime to A to find the middle point right here, because since this is a reflection, B prime to point C is the same as B to C. So that helped me find this middle point, and that is the shortest distance for each of you. And that is all for today, ladies and gentlemen. Check back again next time for another fun geometry lesson.